Hello friends, myself Dr. Narendra Katikar, Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Now we are going to see the details about basics of limits, tolerances and fits part 1. At the outset, the learning outcome for this particular discussion come presentation. At the end of this session, student will be able to understand the concept of size and its types. Student will be able to understand the concept of limits and its types. Student will be able to understand the concept of tolerances also. Let us see first of all why the particular learning and implementation of limit, fits and tolerances are required. The need of particular limit, fits and tolerances. As we know, the manufacturing, particularly any product, is meant to use ultimately in the assembly itself. The manufacturing goes with the manufacturing of the particular parts and its assembly, where interchangeability concept is very important. At the same time, the interchangeable parts require the precision to fit ultimately one with the other. Precision is nothing but the degree of accuracy. To ensure the functioning of part as intended, it is required to provide the limits, fits and tolerances for each and every part being produced. However, experience shows that it is impossible to make the parts economically to exact dimensions. This may be due to various reasons like the various inaccuracies of machines and tools where the parts are being manufactured, inaccuracies in the setting the work to the tool. As we know, normally, traditionally, the work and the tools are required to be held in a respective kind of holders where there might be the presence of inaccuracies. At last, while we are measuring the particular specifications of the product, maybe in between the manufacturing or at the end of manufacturing, there might be error in measurement. We have to consider the same while implementing limit, fits and tolerances. Now let us see some of the terminologies. Allowance and size. The allowance. It is not that particularly meaning as like the tolerance. Allowance is far different than the tolerance. No doubt, in our day-to-day life, the allowance and tolerance we are using in a synonymous way. But from the machine drawing, rather the industrial drawing point of view, allowance is nothing but the difference, rather the intentional difference kept between the two mating parts. As I told, there is a particularly assembly where number of parts are joined together for the particular fitment which results into the expected or defined output from that particular machine. As per the requirement, difference may be positive or negative. While proceeding with the limit, fits and tolerances, first of all, get it understood what exactly the various type of sizes. As we know, after traditional design process, that is applying the loads and other particular conditions to the part, at the end, specifications and sizes are the outcome. Such size after the design calculation is called as basic size. After basic size, we have to imply the various kind of limit, fits and tolerances over there. Such size is called as design size. And the third size is actual size, where after manufacturing the number of similar parts, if we measure the respective parameter for the size calculation, When we measure that particular parameter, that size is nothing but actual size. Now let us proceed with the tolerance. The great care and judgment must be exercised in deciding the tolerance which may be applied on various dimensions of a component. If tolerances are to be minimum, that is, if the accuracy requirements are severe, obviously as we know, the cost of production increases. In fact, the actual specified tolerances dictate the method of manufacturing. Hence, the maximum possible tolerance must be recommended wherever possible. But at the same time, we have to keep in our mind that particular mating of the parts is nothing but the part of particular assembly which is already with a defined output work. So, the balance between the tolerance for the particularly assembly, tolerance for the economical way of manufacturing is very important one. Let us proceed with the one diagram which is illustrating the basic size deviations and tolerances. With this diagram, we'll try to understand the various number of terminologies which are nothing but the basics of limit, fits and tolerances. Basic size, deviation and tolerances are well defined in this particular figure. If you see the left side view, where you can imagine that the shaft element is there which is placed in the hole. Likewise, in the particular assembly, the two elements are considered with their feature, whether internal geometry is going to match or external geometry is going to match. Rather, internal geometry is considered or external geometry is considered. That is nothing but the external feature kind of elements which are going to be applied with the tolerances are called as shaft elements, and the various elements which are being to be used in the assembly with their internal features like a hole, then all such elements features are called as the hole element. Likewise, all the elements mating together are categorized into the two things, hole element and shaft element. You can see now the front view where number of terminologies are displayed. Let us start with the particular diameters which are ultimately getting by applying the tolerances to the respective element. Starting with the shaft, you can see that this is the minimum diameter, this is the maximum diameter of the particular shaft. That means the minimum diameter that can be accepted, the maximum diameter that can be accepted. After manufacturing, if the dimensions fall between these two figures or dimensions, the shaft will be considered as a qualitatively okay. Here you can see that the tolerance for shaft element ultimately nothing but maximum diameter of the shaft that can be accepted minus minimum diameter of shaft that can be accepted. You can see this particular region is nothing but the tolerance for shaft. At the same time, let us see the tolerance for hole element. Just see at the cursor point. This is the minimum diameter of hole that can be accepted. This is the maximum diameter of the hole that can be accepted. The difference between these two diameters is nothing but the tolerance which being applied for the particular hole element. Now let us see the last three phenomena related to the same. As I told you earlier, the different type of sizes. After the design calculations, whatever the size you are getting, that is nothing but a basic size. This is nothing but the basic size, which is also called as the zero line, also called as the line of zero deviation. All the tolerances are given with respect to the basic size. Now, how the tolerances are applied, how you will get the minimum diameter of the hole and shaft, how you will get the maximum diameter of hole and the shaft, that is nothing but with the addition or subtraction from the basic size called as the deviation. Now deviation, as you know, the particularly English word meaning, it is deviated with reference to some reference. So here the reference is the zero line. Now the deviation from the zero line or the basic size to the least one, to the lowest side, is called as the lower deviation. Now the particularly deviation which is nearer to the zero line called as the upper deviation. Now these deviations are standardizedly calculated, which is nothing but the discussion part in our another video. At this stage we have to understood with reference to the basic size, with reference to lower deviation, you will get the minimum diameter. With reference to the basic size, with reference to the upper deviation, you will get the maximum size. Likewise, now you can see the particularly tolerance zone shown for the whole element, lower deviation for whole element, upper deviation for whole element. These are the some of the basics for basic size, deviation and tolerances. I hope you are understood all the terminologies at the outset. The references for these presentations are Dr. K.L. Narayana, Dr. P. Kanaya, K. Venkata Reddy, the textbook Machine Drawing published by New Age International Limited Publishers, New Delhi, and other references are as follows. Thank you.